Hey guys, this is Ronald speaking and welcome back to Houdini Houdono. This is a 10-part simulation series and we are on episode 6. Right, so if you can see on your screen now, it's like a Ferrero Rocher kind of chocolate liquid simulation. It's a nice effect to get started, to introduce ourselves to the flip solvent Houdini. The setup is fairly straightforward. The idea of a flip simulation is complex enough, so we will do a simple setup like this, and as always, the objective is to feel more encouraged about the simulation, right? So let's get to it. So here I have an empty screen. I'll drop down a geo node and call it setup as always, and hide the display visibility, and jump inside and drop down the sphere because a Rocher is like spherical in shape, right? I'll change the polygon, the primitive type to polygon, so I'll get something like this, and I will also drop down a match size node, match size, and change my justify y to minimum to put it on the floor. And right before that, I'm going to increase the division counts and also drop down a mountain node, mountain. And this will allow us to get some irregularities on our chocolate surface. And I'm just going to increase my frequency a little bit more. And for my mountain, I'm just going to adjust the element size so that it looks more like the Rocher. So I think something like this is good. It's a little bit too irregular. It's a little bit too not round, so I'm going to lower the element size and drop down my height. Next, I'm going to just do a little bit more modeling here to make the Rocher look more like a Rocher. To do that, I need to scatter some nuts on it, right? So I'm just going to drop down a scatter node on the surface, put it at the side, and say 200 nuts. I don't need my relax iterations, or rather I'll lower my relax iterations to 1, and I'll drop down the box, and I just copy the points onto those scattered points, and we can see our nuts are looking too huge, so I'll drop down the attribute randomize here to randomize the colors, and another one and change it to p-scale so that I can randomize the overall scale of it. So I'll just bring this down to say 0.1 and arrange it from 0.05 to 0.1 or 0.25 to 0.1. And next I want to get some rotation randomization, so one more, just alternate drag the attribute randomize node and change it to orient. In this case, this is a 4-dimension attribute, so I change the dimensions field to 4, and all the minimum to maximum scale I'll revert back to 0 to 1, so I get randomized rotations like this. Okay, finally I also want non-uniform scaling on the nuts, so I'll just alternate drag the p-scale once again and change this to scale. So I haven't used this attribute all that much, but this basically allows us, if I change this to a 3-dimension axis, it allows us to non-uniformly scale the nuts like this, so we get a bit more variation. Make sure that it's just 0.5 to 1 will do, because I don't want too much variation. And finally, I'll drop a mountain on the box here. Just look through the display flag and see what is generated. Perhaps I need to drop down a subdivision node on the bilinear. Yeah, so I think something like this can result in something quite healthy, right? So this is our scattered nuts, and now we will merge this output together here, and we can see that one of it is colored and one of it isn't, right? So Houdini does this. Right here, I establish some color diffuse attributes on the points, and the copy to points inherits the colors. However, without explicitly defining the color attribute, it defaults to white. However, if I do a combination, it says that on the right side of the stream there isn't a color diffuse attribute, right? It's making a complaint over here. So what we can do is to drop down a color node just to fix that warning. It is not a make or break for the setup, but it allows us to view the mesh better like this. Okay, I think this is okay. Next, I want to actually be rotating this Rocher on the spot. So I'll drop down the transform node here, and I'll just write an expression in the rotation, $ff times 1 times 2 on the x, and $ff times 3 on the y, and $ff times 4 on the z. So they all rotate in different speeds on each axis, so I get something like this. I'll change my frame range to 100 and check the real-time toggle. Right, let's just do a playback. So this is fine, and my match size node allows me to make sure that it's so without any simulation, it's making sure that it's on the ground. Right, so I've got a tumbling Rocher like this. Okay, so now it's time to create our emitter and drop some chocolate on it. So because I'm lazy, I'm just going to use the same object as the emitter. So let me just organize this over here. It's good to it's good to get some names on the attribute randomize because it can get a bit confusing. So change this to CD. This one I attribute randomize to P scale, so I'm gonna just suffix it with P scale, and this scale, and finally this one orient. Okay, so now I'm just going to take my mountain and just do a transform and transform it up by 1 unit, scale it down and transform it by 2 units. I'm just gonna ghost my collision geometry here and select the transform node, press enter on the keyboard and move it up such that it's if I frame it like this, it should be out of screen. So I'm just gonna make it like a 4 units up and maybe 0.2 or 0.3 as an emission. So this will be my flip emitter. So there are two things that we need for the flip emission source is to prepare the geometry for flip simulation. We gotta fill the geometry with some points, and there's a node that helps us do that. And we also need a volume. So the idea of a flip simulation is that it's actually just a particle simulation. However, we need some ability to describe a fluid motion. So volumes are great for fluid motion, and we can use both systems using particles and volumes to create liquid motion. And this is essentially the idea behind the flip simulation. Flip stands for fluid implicit particle simulation, which is a fancy name, but we don't have to really be bothered by what it technically means. Just know that we need to generate some particles and a volume, and the node that helps us to do that is the flip source node that we have it. And next we can just pull down and drop down flip solver. Sadly, there are a lot of solvers in Houdini that has moved to a sub level operation. For instance, vellum configure cloth, right? And right after this, we can drop down a vellum solver right in the sub land, in the geometry land here. The same can be said for rigid bodies, so RBD material fracture, and we can then drop down an RBD bullet solver, and it all will just work automatically without having us to set up our own .NET. Even so, for the vellum solver, we just drop down a pyro source node and the volume rasterized attributes to generate the volume, and then next we can drop down the pyro solver. You see, so you can see that in these three solvers are readily available. It's all these three solvers are just package solvers. If we double click on it, it jumps 2 steps down into the node tree over here, and you can see that actually the .NET is over here. I'm in the middle of a tutorial, and then my cat just decided to sit on my keyboard. Okay, let me try to shift her away. If we jump into the vellum solver, we can see that we're actually 2 steps in. This is actually the forces node in the .NET, so you can see that Houdini has prepared this package node that does a lot of this mathematics for us, so that we don't have to worry about it. Right, the same goes for the bullet solver. If I dive inside, you can see we're actually 2 steps down. If we click on the .NET, this is what it has prepared for us. So all the control happens onto this one node here, and then it's all packaged nicely here for us to use the most common setups, right? The same goes for the pyro solver here. So however, why am I explaining this? Because the flip solver is not packaged up yet. I believe it will come soon. In the meantime, we gotta set up our own .NET for the flip simulation. So we drop down a .NET here, and this is our flip simulation, and double click inside, and lo and behold, it's empty. We gotta create this ourselves. What we need is the flip solver. That's one. The next is the flip object to store our output simulation, and also a flip source, which is you don't see it here, which in this case is called volume source for legacy reasons. And I can plug my object into the first input, plug my source into the last input, and just plug it in like this. Drop down a ground plane, select the first node, select the second node, I'll drag here, I'll get a merge, and I'll just plonk it in here. And I will likely need a static object at some point in order to merge in my chocolate, right? So I'll just prepare that here. So the way this works is we have a solver here. Let me just give it a bit more screen space. We have the solver here. Always, it's usually the case that the first input is the object that we want to store the information of our simulation in. Sometimes it has sourcing options here. You can see that there is a sort path here. So if I go to the first frame, it actually creates the ground plane, the static object, which I have not set up, but it creates these particles over here, right? And we don't want this, so we will delete it under the subpath, and it's gone. Okay, on my volume source node, there are some initialization options here. So I want to source my flip simulation. I will choose source flip, and you can see that automatically it helps me to source the volume that I've created here and some particles that hopefully it's in my source node here. So my input is set to a SOP, which I can then point to my SOP. However, I've wired in here my first input over here, so I'm going to choose first context geometry, and you can see that this happens. I don't have gravity now, so right before my output I'm going to drop down the gravity node, and this is my flip simulation. This preview is not very indicative of the actual body of our particles, so I'll go to the flip object. Under guides, under particles, there's a little tab here. I can choose my visualization to be particles instead, so this is a much closer representation of our simulation. I will need to set up my collision object, which is this static object here, which is not pointing to anything. So on the outside, I will need to drop down a null node to say that this is out, collision geo, and another one for collision VDB. So it is the case where usually, in the case for volumes and flips, usually VDBs work much better as a collision. So I would just drop down the VDB from polygons, pull it from here, and give it a good resolution. 0.1, the default is fine. And I'll just highlight this too as green color. And over in this .NET, I'm just going to click on my static object here, go to my sort path, pick up the out collision geo. However, this is just for visualization purposes. I need to check use deforming geometry. My collision data, I'm actually going to use volume collisions. Go to my volume tab here, choose some volume sample, and in my proxy volume, I'm going to pick up that VDB node. So out collision VDB here. So that's all we need to do, and if we jump to the first frame, it should have resetted it. I can uncheck display geometry and turn on the collision guide here. You can see that this collision guide should be moving, and it collides with our geometry over here. Let me just zoom in a little bit to get a better view. This is what it is now. So you can see that the .NET by default picks up all the objects inside our .NET here, which means it picks up the ground plane, it picks up the static object, it picks up the flip object 1. So I do not want this behavior, so I'm just going to pick up this flip object 1 and put it in here. Then that is where I force the .NET to only pick up flip object 1, which stores my particle simulation here. Right out from here, I'm just going to drop down a particle fluid surface, which meshes the geometry like this. So you can see this is a very low res simulation, but it's the infrastructure for everything that we are just about to tweak. Okay, so I explained very briefly earlier what the flip solver is, what fluid implicit particles mean. You can see here that what it actually does generate is the surface, an indication of a VDB surface of our source geometry, and also a bunch of particles, in this case 100 particles. Okay, I can preview what has been done. Right now the volume is over the particles, so I don't actually see, but let me just, for explanation purposes, drop down a split node. So what the split node does is, if I just choose the volume here, and I'll drop down a null, you can see that visualize volume surface, and another one is to visualize the points. This node is entirely not related to the setup, it's just for me to explain to you that here is the surface and on the other side is the points, right? So the reason why you don't see it here is because the surface is sitting on top of the points. Okay, hope that clarifies. And the main resolution control of our simulation lies in this flip object here on particle separation. So since this would be the master controller, for example, if I change it to 0.01, 10 times the voxel size, you can see the simulation gets much more accurate, but also much slower like this. But on the other hand, if I change it to 1, then you can see that the simulation becomes very coarse like this, and it doesn't really simulate so well, right? So since this is the master controller, I'm just going to change it to 0.05 for now, copy parameter and paste it on my source node, and paste relative reference on my voxel size. It generates a much higher resolution source node. So this is a little bit of a paradox, right? Why isn't it the case where I define the resolution of my source and then feed it into the solver? So the rationale is like just what I just explained. We will mostly be tweaking the resolution of our simulation here. So we want this to be the main controller, and in this case it doesn't cause a loop. because it is just sourcing the numeric value of the .NET in my source node. Okay, so here on my voxel size, I've set it to 0.05, but I haven't done so for particle separation, so I will do the same here. So I get more dense in my source node, more accurate. Also, on my surface node, I believe it also inherits the same accuracy. And also on my meshing, I can paste over here, and it also produces a much more representational mesh of what I solved. Okay, I'm just gonna turn off adaptivity just so you don't lose any resolution, and let's look at the particles here and run a simulation. So this looks fairly nice, except that I would want my emitter to be slightly higher, so I'm going to go to my transform node and change this to 6. And also I think I would want it to have some rotation on itself, so I'm going to do a similar thing I did for the Rocher, the actual Rocher on the ground here, by typing $FF times 2, $FF times 3 on the Y, and $FF times 4 on the Z, right? And what we'll get is something like this. Hopefully it will generate a more interesting source output. Okay, so I'm going to change this. I'm going to drop this down to 0.025, so it's double the resolution now. Okay, so there is a problem here because I don't actually want the chocolate splash to be so messy like this. It doesn't speak so well of my chocolate, right? So I will need to add a little bit of viscosity. In order to do that, we need to enable that in the solver. So let's go to the solver here, go to volume motion, and let's start by changing our velocity transfer to swirly. It's just a different volume transfer algorithm which encourages a more swirly behavior. And also, you can see this purple box here. As I mentioned, the flip solver is a mix of a particle simulation and a volume simulation working hand in hand. And this purple box here, if you guessed it right, is actually the box for the volume simulation. Right, so I don't actually need it to be this big, so I'm going to change it to 5 by 5 by 10, and perhaps just 5 by 5 by 5, and move up the box by 2.5, and maybe 10 by 5 by 10, so I get a little bit more width here. Okay, I think that is all I need. And so I was talking about, oh right, this box is out of bounds of my emitter, so I gotta make this higher. So I'll just give it 10, move it up by 5, so I get a box like this. And just a minute ago I was talking about the viscosity, so we can switch to the viscosity tab here. Enable viscosity, enable to solve viscosity by adaptivity. I assume this will make it faster, I'm not too sure. And the third one is to enable viscosity by an attribute. When you see by attribute, it means that you can write the viscosity attribute to the points, right? So in my source node here, I can attempt to write it here, but I think I will write it after my flip source here. So if I drop down a point wrangle, just type float at viscosity equals to, I'm just going to make a slider here, channel float, CHF, give it a name, viscosity, and do a semicolon to end the line, and press this button here. It's important to press this button, and just give it a viscosity of 10,000. And let's see if our simulation is any different. So I think a viscosity of 10,000 is proving to be too tough. Let's just do 100 and see what that does. So that's really nice, but then I think it's taking a little bit too long for the coverage, so I'm gonna just halve this once more to 50. And next, in order to get some layering folds on the chocolate, I'm just gonna write the oscillation on the X here. So on the X-axis of my transform, I'm just gonna write sine $FF, so that will make it, so watch it, it will make it go front and back. However, it's too slow, so I'm gonna sine $FF multiply by 10, yeah, maybe 20, and just multiply the entire thing by half so it doesn't move that much. And let's see if it gives a nice result. Okay, right now there is a problem. We can see that the particles are disappearing under the ground here. Right, they just get clipped away, and I think it's because in our flip object here we need to enable close boundaries on the minus y-axis, but the rest of it we can leave it open. Right, so that's it. Let's try this again. So overall I think it's nice, but I think our sauce is moving a little bit too vigorously, so I'm just going to change it to multiply by 0.1 is enough. And next, I would like to preview my surface here. This is really nice. Next, I would like to increase some surface tension, because surface tension is a little bit like, you know how mercury tends to form a blob. Once enough volume of it disassociates itself from the main body of water, it starts to form a blob. So that's what surface tension does. It allows for some streaky lines of fluid that happens, and to enable that in the flip solver, it's once again we dive into the flip solver. Under volume motion, under the surface tension tab, I can enable surface tension. Just for dramatic purposes, I'm just going to increase it to 1000, and you can see the difference. Just note that the default is 10, so if it's not a good value, then we can revert. So you can see that the liquid here is behaving very strangely when I increase the surface tension to 1000. Yep, so that is not good. I'm just going to revert it back to 10. I just wanted to ensure that that the surface tension is working, right? So okay, so I think it's looking really nice. Let's just look at our flip simulation here. Okay, so there's some nice layering you can see over here, but some of these bumps look like geometric artifacts, and we can smooth that out by going to the filtering over here. I don't recommend using too much of this, but just to introduce it to you, you can dilate the VDB output, enable a smoothing, and then erode it back. So however much you dilate it will be however much it's eroded. That's just the nature of it. So if I increase this to 10, you can see that we are able to smooth out the result quite significantly. Right, so I'm just going to leave it at the default of 2. And just if I turn it off, we can see what it was. There's some crevices over here, irregularities. If I turn it on, we can solve a little bit of that. And I think this looks natural. Next, I'm just going to reintroduce this left and right oscillation of my emitter over here, 2.2, and just run the simulation again. So this is really nice, but I'm trying to avoid the untidiness of the liquid falling out here. I know it's only natural that it happens, but you know, sometimes for a commercial we need to control this, right? So I think we can stop the emission of the chocolate right about frame 50 so that we don't get as much, and I think we can introduce a central force over here in the middle of the chocolate such that it pulls it will attempt to keep all the particles from falling out to the side but actually flow down the surface. Right, so how do we do that? There are two things I want to do. One of it was to stop this emission at frame 50. So I'm just going to dive into the .NET, go to my volume source, and on activation, I'm just going to write $FF less than 50, it will be activated. So once it's past 50, it will be not activated, right? So that one is the easy one. And next is to introduce force. And there is a node that helps us to do that. It's a very basic node called pop attract, right? So all, as I mentioned before, the flip simulation is nothing more than a particle simulation with the support of a volume simulation at the same time. So in this case, all the particle operators, the pop nodes, will also work. So I'm just going to wire it in like this and just press enter on my viewport. I can move the central location of this up to 1 unit high. So that's roughly the center of my chocolate here. And on the force, I'm just going to change it to 10. As an attraction force, so I think it will encourage the particles to move towards it, right? So let's see how this turns out. So you can see that it's much neater now, and also let's just look at it meshed. We have some layering of chocolate over here. It's really cool. However, I think I don't want it to fully cover the geometry by frame 65, so I think I can turn off my source a little bit earlier, or in this case I think I can remove this here, just let it be activated throughout. It's just the result of that looked like a suddenly someone turned off the chocolate tap, right? However, I want it to feel more like the amount of chocolate is tapering away, so I think instead of just turning it off, I can animate this uniform scale to nothingness by maybe frame 40. So I was using a setting of 0.3. I'm just going to change it to 0 here. Alt click, and maybe starting from frame 20, it's 0.3, alt click, and it will slowly move to nothingness like this. I'm not sure if this is a bit too early, so I'm just going to drag it out a bit more until frame 60, so something like this. And perhaps this will look good. Let me try that again. Yeah, so that I think it turned out better than I expected. Okay, so right now, I know I did say to have it a little bit more controlled, but I think this is too much control. It's not very natural that all the chocolate is collecting at the base of this over here. So I think what I can do is on my pop attract, I can lower my force scale to 5, just halve it. I think it got most of the effect. I think it introduced a lot of neatness in my simulation, but I just need to just get back a little bit of the natural flowing of the chocolate. And I think because I'm turning off my quote-unquote tap over time, I can actually introduce my oscillation a bit stronger now. So let's try this again. We got some really nice forms over here. As much as it is untidy, there's some really nice forms, sheets of chocolate flowing out. One thing I do not like about this is the fact that because our pop attract is really strong, the chocolate that's on the floor is moving towards the center over here. So that breaks the illusion. So I need to at least ensure that the effect of my pop attract only happens near the sphere. So how do I do that? I can jump into my pop attract and only operate on a specific group, and this one I'll call it near sphere. I haven't created this group yet, but I can use a pop group over here, pop group, and just wire it in here and go to bounding, enable a bounding sphere, and just go to the first frame and press enter, and I can move it up by 1 unit and size it up by 2 units. Size it up to 2 units here, and then 2 point, so something like this, right? Within the regions of this chocolate, near the sphere, it will get the attraction, and if it's further away, we will let it be, right? So this group name will be called near sphere, and this pop attract then will operate only on the particles within this sphere. Okay, so let's see if that helps. Okay, I'm happy with this result, and I'm just gonna do some geometry trickery over here. Over here I have the chocolate nuts over here, choco nuts. And then over here I have my static chocolate surface, right? Before creating the particle fluid surface, I can actually combine my static geometry with my simulated chocolate, right? So all I need to do is to drop down a scatter node and scatter 100,000 points all on my geometry here. Okay, so I'm going to drop down a group node to group up all the nuts over here, nuts, and another group node here to call it the static choc static. So in this case, after the match size, I can drop down blast, delete, and then over here I'm going to choose delete the nuts, and what I'm going to be left with is choose the point group, the chocolate, and I can scatter a bunch of points onto this chocolate, and then I can merge these static points with my simulated points, and attempt to do a fluid surface on both these points. Yep, so what we get is, from the first frame, there already is a chocolate surface, and it just merges into the chocolate here like this. So this can potentially avoid some shading artifacts, and our chocolate will still hold true here. So on this delete node, I'll just alt drag here, and this will be our alt chocolate nuts here. I just need to delete the non-selected, so I'll get the nuts. So this will then be our chocolate, choco combined, and the nuts. Okay, so let's just for a quick preview, I'm just gonna alt drag. I can see here, I think the nuts aren't as prominent as they can be. Okay, and I'm going to do a pause here because it's getting late. It's Sunday evening in the studio, and just gonna take a break and just continue the rendering portion at another time. Okay, I'll probably continue this another day, maybe split this into a two-part thing. Right, just gonna save my file now. So let's continue. The last time, I think it was last week. Yeah, the last time I was still working on this. Let me just see where I left off. I've got my .NET here, and it's emitting a bunch of particles like this. Let's cache this in order for us to work properly when we're rendering. So drop down a file cache node, and I'll add a suffix called chocolate flowy over here, and I'll add another node, another file node, and also affix a suffix called choc flowy, so that I know that these two are tied together, are meant to work with each other. And then I'm just gonna wire it in like this, and I'm just gonna press save to disk. Okay, so the cache is done. Select the file node, click on here and navigate to your current hip file, and it should be there in Geo. And I'm gonna pick version 2. This is my demo file here, and I can see chocolate flowy over here. Now here comes a trick question. Do we want to also cache this particle fluid surface? Because you can see that if I click here, it's instant because it's just merging these two streams together. If I click here, it's quite instant, but if I click on the particle fluid surface here, it takes a while. If I change a frame, it takes about 3 seconds in order to generate this geometry from the particles over here. And this is in full acknowledgement that you add 2 to 3 seconds to calculate this surface. But if you cache it into a geometry, you might get a diminished return if the data that you saved, it takes more than 2 to 3 seconds to load up that amount of geometry data. I hope that makes sense. So this is the case where right now it's deterministic already if we put down the particle fluid surface node from the particle cache here. So I think it's quite safe to say that we can proceed with this. And if you notice that over here that there are some irregularities on the surfaces over here, and there's a way to counter that if we turn on the dilation here and also the smooth over here, and we are able to slightly smooth out the surface here. Usually the defaults are fine for medium to small scale simulations. Okay, so let's lights camera action, right? Right now we don't have our geometries, we don't have the action. So let me just kill this merge node, and I need all these 3 nodes to be available outside. So I jump outside, drop down 3 geo nodes. The first one being chocolate flowy, choc flowy. Next being the chocolate nuts. Let me just get the names to be exactly the same. This is choco, this is choco nuts. Okay, so let me do that. It's choco and choco nuts. Okay, so inside the choco node, drop down object merge, navigate to the setup and find out choco, and on choco nuts drop down an object merge and navigate to choco nuts. So we have 2 geometries over here, and over time we can see, oh, I love the folds over here. Okay, so we're ready to light. We've got our action here. We need a background, so drop down grid as usual. So this, let's call it BG1, and alt drag twice, and we get BG2 and BG3. For BG2, select the node, press enter on the viewport, and you can rotate this 90 degrees, move it back a little, and do the same for BG3, rotate it like this, rotate the x-axis by -90 degrees, and you can build 3 walls very quickly like this. Okay, next is to drop down a camera. So I'm just gonna color my main geometry nodes green color and my secondary geometry nodes a light blue color, and drop down a render cam. So camera, and I'll call my camera render cam. Next, if I click here in the viewport, I can choose render cam, and I'll be able to select these 2 nodes, and spacebar F, I am able to frame my geometry like this. Okay, I have a preference to shoot. In general, the front axis for Houdini is the Z axis, and that's probably where I've staged my simulation to look the best. So I think I moved these planes the wrong way around, and a quick way to rotate this is to drop down a null node. Let's just call this BG rotate, and parent all of this to BG rotate, and I can just click on the null node, and rotate this null, right? So I'm just going to rotate it 180 degrees, and then voila, I'm looking at it the right way. On my camera, let me now choose the render cam over here. Click on here, choose render cam, and click on the padlock. Select my Choco and Choco nuts and spacebar F. So now with the padlock selected, I'm actually tying my viewport navigation and manipulation to my camera, so I'm essentially moving my camera. Okay, so get a nice framing. I will choose a longer focal length like this, 120. Oh, what's that gizmo? And I can notice that I don't have enough floor, so on BG1 I'm just gonna scale it up by 2, so I get more floor like this, and I'm just gonna frame my shot like that. And for those who know the drill, I like to add a little bit of an orbit and a camera shake to my camera. So drop down 2 null nodes above here. One of it, I'll call it an orbit. The other one, I'll call it shake. And I'll parent my camera to the orbit and parent my orbit to the shake. And on the shake, I'm just going to right click on translate and choose motion FX noise. I will change my period to 3 and harmonics to 1. And I can see that in my graph, it looks like believable handheld camera motion. It's just that the amplitude is a bit too large, so I'm going to change it to 0.5 instead of moving 10 units. And you will notice that if I scrub the timeline, it's quite laggy. I'm not able to very well preview my camera animation. So in order to deal with that, I'm going to hide the Choco geometry so that the viewport moves quite quickly. I get more real-time feedback. So I'm going to hide my null node over here. I don't need to see them. Hide the display of the null nodes. And for my orbit, I'm going to just put $FF multiply by 0.2 on my rotation Y, so I get something like this. It's moving a little bit too far to the side, so I'm just gonna, on top of this expression, put -30. Maybe -15 is enough, so I can start somewhere here and end somewhere here. Okay, so now I can, I'm happy with my camera move. I'm just gonna go to the middle frame and start to design the materials, right? Let's start with the Choco nuts. Let's jump over to the Redshift tab. And over here in my OBJ context menu, my network view, I'm just gonna press Ctrl 1 with my mouse hovering over it. This will set a quick mark to 1 so that the next time I press 1, I'll navigate quickly here. If I go to my material context, press Ctrl 2, my out context, press Ctrl 3. And while I'm in my out context, drop down the Redshift render node and be sure to go to your IPR options and choose live SOP updates. Okay, this is important. If not, if you scrub your timeline, the geometry doesn't get updated. I have a preset that I use here. Okay, set some good defaults. And next, I'll go to the material context here, drop down 2 Redshift material builders. Order 3 of them. So one for the chocolate, one for the nuts, and one for the ground. So this one, I'll call it for the ground, Choco nuts, and Choco. You can color it dark brown, light brown, and the ground maybe a complementary color. So since we're doing Rocher here, maybe you keep it gold like this. Yeah, so sometimes, this is the good thing about the nodes in Houdini, right? You can color it and it's quite easy to tell once you if you haven't been working on the file and you open the file again and you just want to, at a glance you can tell like which material is for. If you want to adjust the chocolate, it would be this material, right? Okay, let's do the material assignment. Just go to the scene view. Let's show the chocolate. So press 2, drop the chocolate onto the chocolate, and I cannot see the nuts over here, so I'm going to click to frame 23, drop the nuts onto nuts, and drop the ground onto these 3 planes over here. Okay, and now I need a light. So let's move the camera stuff over here. I like to color code my stuff, so all this shall be blue. Maybe this shall be another color of green, like this. And my setup, I can color it red, so that's where I control all my stuff. Okay, and now I need my light, so RS light dome, and I'm just gonna pick up an HDRI that I always use for this whole series, and I'm just gonna press not enable in the viewport, and I'm just gonna go to the render view and press render. In order to get some quicker feedback, I'm just going to press this button here, go to fixed scaling, and change the second field here to 50. So we're essentially rendering only 50%. That is usually good enough for us to do some look depth and surfacing work. Okay, so now I'm going to go to my chocolate here and change. Chocolate is brown, so I'm just going to choose a deep orange and lower the brightness here and change it to something deep and dark like this. Less saturated maybe. And if the chocolate is in its molten state, it's a little bit more glossy, so we can write some attributes such that as it settles down onto the body of the chocolate, it gets more rough, but let's not get too advanced with that. In general, the chocolate is actually a lot rougher than my memory serves me. I remember looking at the reference and like, oh, the chocolate is quite rough, right? So let's set the roughness of the reflection here to 0.5, and this is much closer. And let's for a moment handle the nuts. The nuts over here, we're gonna choose, I think I can hide the chocolate for now. And on the nuts over here, I'm gonna choose on my diffused color some pale yellow like this. And for my background, I'm just gonna use, I think because Rocher is always packaged in the gold foil, I think we can go with gold color. So I'm just gonna choose gold. It's a Redshift preset, and this is very reddish gold, and I think it's got to do with my environment here. If I were to select my dome light and reduce my saturation of my light, I get something less red. So there is something nice about this color over here actually, so I'm just going to put 50% of that. And also, I don't think the background has to be so glossy. I think I can increase my roughness here to say 0.5, 512. I think it's quite nice when we get some nice reflections here. So I believe I can add a texture to this somehow later, right? We'll see how that goes. So now let's unhide the chocolate geometry, and we can see the very nice flowing of the chocolate. So let's just make sure that the light direction is good. So I'm just going to click here and choose clay and select my light dome here and just go to rotate my light such that I get a nice cutting diagonal to stay consistent throughout the series. Yeah, so we can pay attention to so sometimes when we cheat it, we can see that the source of our emission is here, right? So we have to maybe zoom in a little bit to avoid that thing from being seen. So 130 and maybe 135, right? So we get closer. Yeah, I think something like this is okay. Maybe just 140 will do. Okay, this is fine. Change it back to regular, and there is a grid texture on the Rocher, which I think I can replicate onto the floor over here. So allow me to find a grid texture. So I think I'm quite lazy to try to generate a grid texture to find a texture. So I'm just going to go to the floor over here and uncheck my padlock here and go to the display here and hide the other objects so I can concentrate on my ground plane. Press Shift W, I can see the different grids over here. I'm just going to do some very expensive extrusion, but so long as so I'm just gonna subdivide this a lot and try to generate a grid, right? So let me drop down a subdivision node and choose bilinear subdivision, divide it by maybe 4 times, so I get a lot of divisions here, and even 5 times. After which I think I can do a poly extrude, and instead of extruding the whole thing, I'm gonna extrude per face by choosing individual elements and just a distance of 0.1, and I'm just gonna give it an inset of 1. So I think the division count is quite high. I cannot see what I'm doing enough, real time enough, so I'm just gonna drop to 3, and the inset I'm just gonna give it 0.01, right? So this I'm just gonna generate the illusion of the foil like this. So just a little bit will do 0.01. Go to my subdivision surface, change it to 4, and drop down a normal node and make my normal cusp angle to 0 so that it's very sharp like this. So let's see how well this looks in the render, right? So we get some impression of the foil. I think it's a bit raised a little bit too high, so I'm just gonna jump inside. Let's lower this to 0.02, 0.03. Yeah, I think this is okay. I'm just gonna change my subdivisions to 5. Yeah, so just make the environment a manifestation of what the product generally looks like. And you can notice that most of the nuts are hidden by now, so that's not a very good sign. It doesn't look like the Rocher. So let's try to fix that. This is a modeling fix. If I go to the setup here and just look at the .NET, or rather the area where I model the nuts, I can potentially, so this is where the nuts are output, I can potentially make the nuts a bit bigger. So over here on my randomized scale, I'm just going to increase p scale, and I'm just gonna select global scale and multiply by 2, so it's a bit bigger. So this should serve us much better. And I'm just going to, right before the output, I'm just gonna drop down a normal node and change also the cusp angle to 0 so that they look much sharper. And go to the Redshift route, just hide the chocolate and just have a look at it. Yeah, that looks fine. If I check the chocolate, then we can see more of the nuts over here. And if you look at a photo of the Ferrero Rocher, if you zoom in enough, okay, so I have some trouble over here. I can see the polygons, right? So I'm just going to go to render only this area here, just with the bucket render, and drop down around corners here and drop it into the bump map like this. And you'll see that we can dial in the look of the rounded corners. Let's just change this to 100% for a moment. So when the radius is 0, so it's very sharp like this. When it's 0.1, we can get some rounded off. 0.2, I think 0.1 is fine, so let's leave it as that. And on the material, I should put some roughness onto it and give it some divisions. Okay, so zoom all the way back out and run the render, turn off the render region. And next, if you look closely at the photo of a Ferrero Rocher, so here's an image of a Ferrero Rocher I found on the internet. We should see that while the nut sits in the chocolate, there is a sense of some translucency also, that the chocolate is actually almost forming a crater and just moving towards the way the nut sits on, right? So we can mimic this by displacing the geometry. So let's see how we can create this effect, right? So let's jump over to the modeling again. So right before I output this over here to scatter a bunch of points, what I can do is change the modeling of this so that it forms a little crater to hold the nuts over here. Okay, so the way to do this is to transfer some a fall off attribute and displace this geometry based on that attribute. Okay, so how do I do that? If I drop down point wrangle here and just define that my fall off equals to 0. So this is to set it to 0, set 0. And I will make another one here, which is only for these nuts over here, set it to 1 and set it to 1. So here my fall off is 0 and here my fall off is 1. So I'm just going to drop down an attribute transfer, which transfers an attribute of your choice by distance. So the second input is the one where I want to steal from the nuts over here, and the attribute I want to transfer is not the color. I'll uncheck primitive attributes, and specifically I want to pull the fall off attribute here. And under the conditions tab, I can adjust how much I want to pull, how much of the fall off attribute I want to transfer. And you will notice now that there isn't a way to visualize this, right? So with the node selected, I press X, it drops down a visualizer here. If I click on it, go to the second tab over here, and instead of visualizing the position attribute, I'm going to visualize the fall off attribute. So you can see that on my geometry over here, so delete selected, I get my geometry here. So I noticed that this geometry is with the nuts included. I'm just going to copy this delete node here and choose delete selected. So I'll delete the nuts group and I'm only left with my chocolate geometry. So now it's been set to 0 and I will try to steal the fall off attribute from the nuts, right? So this is fall off here, and the reason why it's all black is because it's set to 0. So if I increase it a little bit, you can see that it steals the point attribute from these geometries over here. Okay, just that maybe it's not very dense over here, so I'm just going to drop down. Okay, I'm just going to move the collision nulls out of the way and make it clear that I am working one on the. So I'm just going to delete these two delete nodes and drop down a split node instead, so that's much clearer. So this split node can split my geometry into two parts, one of them being the nuts and the other being the chocolate, right? And then I'm just transferring the attributes of the fall off that I'm trying to create over here over to this side. So I'm going to set the distance threshold to 0 and just slowly increase the blend width to get something that I need. something like this. And I'm just going to displace my geometry based on these values over here. However, this geometry is, I think it could be one more time more subdivided. So I'm just going to drop down a subdivide node so that I get a little bit more geometry. Maybe I do this before, and then when I do the transfer, I get a bit more geometry to play with. And I'm going to displace it, right? So let's drop down a point wrangle, and to displace it, the function is like this: at p plus equals the fall off, like this. So everything displaces a whole unit positively on the x and y and z axis. So in order to introduce some direction to this, I shall multiply by the normals at n multiplied by the fall off. So it displaces outwards quite a bit, and we want to control the magnitude of this. So I'm just going to add one more control here, multiply by my own slider here. I'll just call it displacement, displace amplitude, and press this button here, and I'll get this displacement amplitude slider here, and you can see that I can control how much I want to displace, right? So once that is done, I'll just drop down one more normal node to recalculate the normals in case it looks weird. Yeah, so we can see it like this. So let's look at it merged over here, out choco and out nuts, just as a preview. You notice that the chocolate is black, so I'm just going to drop down a color node here so that it's white, and you can see here is my displacement point wrangle. So if I call this displace, I can see how much it matches, right? So right now it's a bit difficult because it's trying to calculate the particle fluid surface, so maybe I just merge it here. It's fine. And I can see that based on where there are nuts, it will just displace my geometry. And you can see that I want to have some level of control. It's linearly pulling the it's either 1 or 0, and I'm not able to control the amount of gradient. So I'm just going to add one more thing to this fall off, which is a channel ramp, ch ramp. Call it ramp fall off. And the attribute I want to manipulate is the fall off attribute. And I'll introduce some control on my fall off attribute here. Press this button and I get this ramp over here. Select both handles and set the input interpolation to B-spline. And I can choose to kind of like non-linearly push out this the parts of the chocolate. And once that's done, you can see that it's a bit jaggy here. So after I'm done with this illusion, so let me enable and disable. You can see what this does, right? It creates some sort of geometry to hold the nuts over here. I'm just going to drop down a smooth to smooth out this effect here, and look at the normal node, right? So let's one more time, let's enable and disable the effect. You can see. And why go through the trouble to do this is because we can also use this fall off attribute for shading. Okay, so under the particle fluid surface here, if I middle mouse, you will see that there is no more fall off attribute. Okay, so what we can do is to once more use the attribute transfer to transfer the fall off attributes from my chocolate over here. So if I use my visualize node over here, you can see that this chocolate has some fall off attributes, which I can pull it straight from the chocolate here, and then lower my distance threshold and increase this slowly. So I can use these values for my shading, right? And also I can drop down a smooth node, smooth only the fall off attribute, so that I can get some blurring over here. Okay, so in this case, I can also affect the shading of my geometry, and I think the nuts geometry is not holding up so well, so I'm just going to also drop down a subdivide node to subdivide the geometry, and drop down a normal node after. However, it's getting a little bit too round, right? So right before the subdivision, I'm just going to add a crease node, and I'm just going to adjust the crease weight until it's something that I think works. Okay, I think this is fine now. So you can see that we have some craters that is holding onto the little rocks over here. So it's more believable this way. So all that work is to allow us to achieve a more believable Rocher here. Right now, you can see clearly that it's just sticking onto the chocolate. It's not looking very convincing, right? So let's kick off the render again, and we should adjust the shading. So under the chocolate, I can drop another shader here, another material here with a Redshift subsurface scattering, and choose one of the presets here, maybe skin brown, so that we can mimic the thinner surface of the chocolate. Maybe change the scale to 0.1 or 0.01. I think let's start with 1, and then I can drop down a Redshift material blender and blend between the base material and the first material. And what attribute are we going to use to blend this? If you guessed it right, congratulations, it will be the fall off attribute. So let's drop down a point attribute here, type fall off over here, off, and plug it into the blend color. So let's restart the render to pull the attribute, and you can see, alright, there's a typo here, fall off, fall, if I can spell correctly, fall off, right? Double L, double F, right? So if I click off the render, I'll be able to see that this is my fall off attribute, and I can blend between the two materials using the fall off attribute. So if I select my material blender, I can see the two materials blended. Can I? I cannot, because the base material should be this base material. Let's just swap it the other way around. Refresh the render, and you can see that nearer the surface of the chocolate, more light passes through, right? I can also use this fall off attribute to do a displacement. So it's I think we can see here that we gave it some surface definition here, right? Using our own displacement, our viewport, our geometry displacement. But after we scatter quite a bit of points over here, and we do the particle fluid surface, and probably because we are at the end of the simulation, we are not able to, we lost a lot of, we got a lot of chocolate covering the geometry, right? So if we go earlier into the simulation, it's probably a better assessment. So you just go back to the render cam, just kick off the render again at frame 9. Now you can see that we get the illusion of wherever there's a chocolate, there's something holding it, and more light is passing through, right? So now we can dial this in. For example, on the subsurface scattering here, I can reduce the amount of light that scatters through by dialing down the scale. I can also adjust the fall off attribute in render time. So just drop down a redshift ramp, and I can pull the ramp such that only at the areas that are very close to the nuts, we will get the see-through effect, right? Okay, with that, I will jump over to the choco nuts here to just make sure that we can introduce some subsurface onto the nuts over here too. Okay, so just gonna select the round corners, just gonna drop it down to 0.02, and then I think just going to reduce the saturation quite a bit, reduce the brightness quite a bit, because it actually doesn't stand out as much as the color that I chose just now. Okay, so something like this. And if we wanted to, we can use the fall off to drive the displacement of our chocolate once more. So let's attempt to do that. So the same point attribute here is fall off. I can put it also into a ramp and just fit it into the displacement. Right. Just before you do this, it's probably a good idea to go to the Redshift OBJ tab, go to tessellation, enable tessellation, and enable displacement. And with that, go to the shading. Before I plug everything in, I'm just going to put the scale to 0.1 in case it explodes. Put the texture map in and drop down into the displacement. And you can see it pushes out the geometry quite a bit. Right, so it's 0, it's like this. Let me just save this frame. So 0 is like this, and with the displacement, it's like this. So without and with, without and with. You can see it's that much more convincing. Okay, so I think I'll introduce just a little bit somewhere in between these two, and it looks very much like the chocolate already. I think we can improve on the shading of the nuts by choosing a redshift subsurface instead, or I can turn it on here. Oh, I'm just lazy, so I'm just going to use a subsurface RSSSS and choose a preset skin brown and change my scale to 0.1, and this looks a lot better. Okay, so we are almost done. Maybe 0.01, yeah, 0.05 is good. And maybe I will just increase my subsurface samples here to 512 or 1024. And on my primary color here, I'm just gonna increase the brightness just a little bit so that the nuts stand out. So that's how we can achieve a more photorealistic look of the Rocher procedurally. Okay, so if we navigate down the timeline to frame 60, maybe the chocolate covers most of the nuts, but we will still be able to see some of it, right? Okay. So maybe at this point you might want to tweak the simulation, but I think it looks quite cool like this. Okay, especially all the layering over here. So the gold foil motif that I was trying to achieve with the floor is the one over here. You can see that there's a grid pattern over here. Okay, so I think just for good measure, so what I feel is as I mentioned just now, so in the case where the nuts are not pushing through quite as much as we wanted it to be, we can once again jump into our geometry here, go to the P scale here and change this to 3, right? So we get even bigger nuts over here. Okay, so now if we navigate back to the rendering here, press playback and we will see even more, right? So if I go to frame 14, yeah, so it might be a little bit heavy-handed, so you can just do the taste. But after it's covered in chocolate, 2.5 is enough, I think. Just refresh the render. Yeah, so I think the idea is that we can get all these translucent effects as the chocolate sits inside. We can adjust it a bit more in the shading. Here, maybe get it more exposed towards the chocolate. Yep, something like this. We can see through the surface of the chocolate. Okay, I think the chocolate is a bit lost in all the gold, so I think I'm just going to make sure that one of the plane here is white color. So let me make another ground here, just a white wall. Choose it and just choose a default plastic and drop down and assign that material there. So let's choose a white color for this one, so that it brightens up the image quite a bit. And maybe for both walls, right? So for BG2 also, let's choose white wall. Yeah, I think that works. Okay, so this concludes the shading portion of this tutorial. I hope you enjoyed this tutorial as much as I did, because making food renders is quite fun. And also I think it's quite a nice cost-effective effect, you know, with just some nodes we are able to achieve something quite nice like this. And it's also, I think it's a good introduction to Flip, because a small scale simulation like this is not too expensive, I hope. I hope your machine can keep up with this. And yeah, please let me know if you try this out and you achieve some results. Please don't be shy, tag me on Instagram. My handle is Ronald_Fong. So this is my Instagram. You can see that for the past 5 episodes of Houdini Houdono, there are some slides here. If you need some offline notes on how to achieve the effect, I'm just gonna make the notes also for this episode. So this is episode 6, and we got 4 more to go to conclude this series. Yep, I can't wait to see what you guys come up with from this series, right? Okay, please let me know if there's any feedback. I noticed that some of you have mentioned that you guys are interested in the futuristic HUD or FUD design using Houdini and Redshift. So I'm going to do that. And also a request from one of my students mentioned to cover something about materials and shading with Karma. I'm not too familiar with Karma, but I think I can do something to help the students out. Right, okay, so that will probably be an episode that I will try to weave into Houdini Houdono, I'm not sure. But that probably will be a couple of episodes later. And so yeah, what we're gonna do in the next episode, I think we are done with flips. We can do some volumes, right? So I'll think of one of the most classic effects of volume. Maybe not just make a plume, maybe something that interacts with a product or something like this, so that it's a practical knowledge that we can apply onto our production. Let's see if there's anything else I need to cover. So yeah, please DM me on Instagram. You can DM me Choc on Instagram, and I will drop you the annotated version of this file. So right after this, I'm gonna spend some time to annotate the file, and I'm gonna save it, put it somewhere. Go and drop me a DM. I'm going to drop you the link to the file. Right? What else? Yep, so I think there's nothing else I need to cover. Hope you have a good weekend learning this effect, and yes, please tag me if you have something. I'd love to see what you guys come up with. And with that, I'll see you next week. I'll upload a video every Friday Singapore time, Houdini Houdono, this mini simulation tutorial series, and I'll see you guys next week. Right, once again, this is Ronald speaking, signing off. Bye.